everybody, the last video for section 4.3, determining extrema and points of inflection using charts, right? And we'll spend some time working on this graphically in class. We didn't do a lot graphically because it's really a lot easier to do when we're right there to talk about ideas. But I think we can handle the charts. So using using charts to determine extrema and points of inflection. Well, let's just first of all take a look at this one. Remember, let's talk extrema. We would have to see that the first derivative was 0 or undefined, right? So for extrema, that's what we look for. And we look at our chart and we say, well, is f prime ever equal to 0 or is f prime ever undefined? Because that's potential. And I do see a place right here, I'm sure you do too, where f prime has a value of 0 at x equals 2. And then we want to look, so this is a potential, it's a candidate for a min or a max. And then we want to look to see, does f prime really change signs right at 2? And the answer is yes. It's negative all right up until we get to 2. Boom, passes through 0, and then now the slope is positive. And so this would be, you'd have to think, well, if at x equals 2, if the slope of f changes from negative to positive, that means we have a min at x equals 2. So you're doing the same thing you did algebraically, finding candidates. It was never undefined. It would just say undefined right in here. And then checking on the left to the right to see if there were really sign changes, right? Nothing to it. Okay, until I get to example 2. And I already answered that question, right? A min at x equals 2. Okay, and your job here is to check out what you think about this next one. Are there any extreme? I'm not too worried about points of inflection because we need some second derivative information on that. We'll do that next. I just have 3 examples. So take a guess here if you think you might have some extrema. Now I'm going to go ahead and say we might have extrema at x equals 2, and that's because f prime equals 0 there, okay? That's totally potential. There is a problem, though, with just saying, oh, look, we're negative on the left and positive on the right. I want you to picture how much space there is between the numbers 1 and 3, and I'm going to help you picture that here. Okay, so x of, we'll say, 1, 2, not to scale, 3, never is. Okay, and what we know is that somewhere we might have a slope of 0, and we have a negative slope over here somewhere and a positive slope over here. So there definitely is a minimum somewhere in here, but it doesn't mean it's at 2. There's so much space in there. Look what I can do. I can draw a negative slope, right? F prime's negative, and then I can go to a positive slope over here at 2. And then, oops, missed my point. And then I can go negative, positive, negative, and then I'm supposed to end up with positive slope here. Look, I drew this with 1, 2, 3 relative mins and 2 relative maxes in there. And notice what I put at x equals 2. I made it a max, not negative to positive. But I did say if the slope changes from negative to positive, there's a min somewhere in there. I actually plunked down 3 of them for you. But there's no guarantee that it's right there. Okay, but we do have some other information, and this is when the AP exam forces you to use the second derivative test. I'm going to put some other numbers in the table. And now we know that at 2, the slope is 0, like I've drawn it, and the curve is concave down, which I actually ended up drawing on accident. So that would make it a max. So f prime at 2 equals 0, and f double prime at 2 is less than 0. It's negative 7. Therefore, we have a max by the second derivative test. Okay? Alrighty, and this is our answer. Okay, and the last one I'd like to look at here is a little less tricky. Let's just look and see if you can find any points of inflection. You know you have potential for points of inflection when f double prime equals 0. And I do see f double prime equals 0 at x equals 1. And then your job is to determine, is this enough to justify a point of inflection? Does the sign change of f double prime occur exactly at x equals 1? And the answer is yes. We have a point of inflection at x equals 1 because f double prime changes sign exactly right there. Everything less than 1, f double prime is positive, so f is concave up. And then everything immediately after 1, f double prime is negative, so f goes to concave down. So we are changing from concave up to concave down. And that is a point of inflection. So be careful. The graphs with the less than or and equal to the inequalities there usually work out a little nicer. These, remember how much space there are between numbers. All right, that's all I have for you. Last video, thank goodness. All righty, folks, take care.